This is a really challenging environment for wireless. First of all, you're subterranean. How do you get coverage down underground in the subway system?
As you can see, the trains just don't stop coming. So one of the significant difficulties with the subway is it is 24/7, which we're seeing behind us.
You're going to get a crowd of people that are going to just slam the capacity of the system. Then they're going to get on a train, they're going to go away, and then the process repeats itself. So you need to design a system that is able to provide for those capacity spikes.
So what we're going to be showing you is the components of the DAS and the Wi-Fi network, which includes the antennas and the Wi-Fi access points that are above us, as well as the remote node that Solid's provided. These are the essential parts that provide the service in the subway.
One of the interesting things architecturally that Transit Wireless has done in their design is, given the limited space of the subway tunnels, is to use base station hotels as a way to organize the head-end equipment in a way to serve multiple locations. It's a way of getting around the challenges of limited space.
So what is a base station hotel? Because I've heard that term a lot in the last 2 weeks, but what does it really mean?
Yeah, it kind of is what it sounds like. It's literally a location where you hotel or you group the base station head-end equipment from the wireless operators as well as the DAS OEM in this case.
The carriers themselves like this because they can bring their techs to this one location. They're not in the subway working on the equipment. So what we're looking at here is this is one of the Tier 1 operators' base station equipment. This is a typical base station that you would find in any base station for a tower or top of a building. Inside this equipment is their GSM, their 3G, and their LTE equipment. Each one of these base stations, which holds up to 3 sectors, will be feeding 3 different stations throughout the network. So this location can hold 60 sectors, which in our terms is 60 stations. So from this point on, you can see that there's a significant amount of fiber that comes in, and this is the backhaul equipment for the carriers to bring into their base station. From this point on, this is actually the RF component, as if we were going to the top of a tower onto antennas, but from this point it's distributing over to the head-end equipment. These are what we call DAS trays, and essentially the carrier equipment comes in at a high power level, and the equipment that goes for our head-in is actually a low power level.
So those big cables from over there, those were
for high power coax cable.
High power, it's got to come in here and you got to step it down.
Yeah, so these essentially are stepping down from the carrier high power, taking away significant amounts of power down to the low levels that's required by the head end. So each carrier will have similar sort of equipment, and the advantage of these trays also give you the ability to adjust the levels into the head end equipment, but also make additional optimization on the uplink side when there's a different noise floor in the station. This is now the head end of the facility. So this is essentially the central component for every single station. So this is where we take the inputs from every carrier, so from 2G, 3G, and 4G, and combine them into a system that we can communicate to the station. So what we're looking at here is each rack is essentially 2 stations. So his station number references to the MTA's association for a station. So this may be 33rd Street or something like that. And then each sector has each technology inside it. So
do you have different boxes for each carrier, or are you actually aggregating multiple carriers into one box?
It all aggregates into the same box, but essentially the system is broken up into bands. So obviously on our system we have 700, we have 800, we have 850, 1900, and 2100, and we'll keep expanding that. So the advantage of this system is it's flexible enough to add different bands and add different carriers to the network. From this point on, there's a single fiber that leads to whichever station this is connected to. This is the massive amount of batteries that they provide to protect their equipment. So essentially, the power to this building was to go down. We wouldn't want to lose all the equipment in this building because that would affect what's in the subway. You can see there's a significant amount of equipment here, and this is extremely heavy equipment, so all the flooring has actually been reinforced with steel to ensure that it's held up inside this building.
So Nathan, this is our last stop on our Transit Wireless tour. Talk about how the fiber comes in, the fiber goes out, and what we're looking at in this room.
So obviously, feeding fiber from this room needs to go out into the street. So from this point, the head end connects into fiber distribution frames that converts onto our 864 fiber that goes out into the street. So as you can see up above here, this is actually It doesn't look like it would hold 864, but this is 2 reels of 864 fiber. So from this point, you'll see this cable runs both into the transmission room or the base station hotel, and then it runs down the conduits down through the floor into the street. So the fiber from this point is actually running through the conduits in the street and in the building.
So how many bars do you get on your phone? We're down the subway.
I'm at full bars right now. Yeah.
And are you happy with your phone service?
Yeah, I'm extremely happy. I'm able to call, I'm able to text, I'm able to go on Instagram, Twitter.